Hey data enthusiasts, welcome back to Let's Talk About Data, where we break down the world of data science, analytics, and AI. I'm super excited to introduce a brand new series, Weekly Data Science Projects. Every Saturday at 7 p.m. CET, we'll explore a new hands-on project, breaking it down step by step. Whether you're a beginner, an intermediate learner, or an advanced practitioner, there's something for everyone. So, why are we doing this? The best way to learn data science is by working on real projects. Not just watching tutorials, but actually building something that adds value to your portfolio. Each week, we'll pick a different project from various domains: machine learning, NLP, time series, computer vision, and even deep learning. We'll discuss the problem statement, dataset, tools required, and step-by-step implementation. By the end, you'll have a fully working project. For our very first project, we're diving straight into an exciting topic: customer segmentation using K-means clustering. Businesses use customer segmentation to group users based on their purchasing behavior, demographics, and interests. This helps in targeted marketing and better customer engagement. We'll be working with customer transaction data and using Python libraries like Pandas, scikit-learn, and matplotlib to perform clustering analysis. Let's quickly go over what we'll cover. Understanding customer segmentation, pre-processing customer data, applying K-means clustering, visualizing the clusters, interpreting results for business insights. For this project, you'll need Python installed on your system, Jupyter Notebook or Google Colab, Pandas, scikit-learn, and matplotlib libraries. The sample dataset, link in the description. Don't worry if you're new to any of these, I'll walk you through everything step by step. Now, let's dive into the code. We'll start by loading our dataset, exploring its structure, and preparing it for clustering. Then we'll apply the K-means algorithm and visualize the results. To keep things simple, I've prepared a Jupyter Notebook with all the steps, and you can follow along by downloading the dataset and code from the description below. This dataset contains customer information from them all, including customer ID, unique ID assigned to each customer, gender, male or female, age, customer's age, annual income, $, the annual income in thousands of dollars, spending score, 1 to 100, score assigned based on spending behavior, importing necessary libraries. Loading and exploring the data. Here's a glimpse of our data. We'll focus on annual income and spending score to perform clustering. Visualizing the data. This scatter plot shows how customers are distributed based on income and spending habits, but we need a way to identify clear segments. Finding the optimal number of clusters, elbow method. Before applying k-means, we need to determine the optimal number of clusters, k. We use the elbow method. This graph represents WCSS within cluster sum of squares against different k values. The elbow in the curve indicates the optimal k value, usually where the drop in WCSS starts slowing down. In our case, the elbow appears around k equals 3 or 4, so we'll use k equals 3 for better segmentation. Applying k means clustering. Now, each customer is assigned to one of 3 clusters. Let's visualize them. Visualizing the clusters. Each color represents a different customer segment, and the yellow X marks the cluster centroids. This segmentation helps businesses tailor marketing strategies to each group. And that's it. We've successfully grouped our customers into clusters based on their behavior. This technique is widely used in marketing, e-commerce, and finance. I encourage you to try this yourself and tweak the number of clusters to see how it affects the results. If you found this useful, drop a comment below and let me know what you learned. And don't forget to subscribe because next Saturday, we're tackling sentiment analysis on movie reviews, where we'll build an NLP model to classify reviews as positive or negative. Hit that like button if you enjoyed this video, subscribe for more weekly data science projects, and ring the bell so you don't miss our next episode. Also, if you complete this project, share your results on LinkedIn or Twitter with the hashtag Let's Talk About Data. I'd love to see your work. See you next Saturday at 7 p.m. CET. Until then, happy coding. Hey data enthusiasts, welcome back to Let's Talk About Data. You're watching our weekly data science project series, where we break down hands-on projects every Saturday at 7 p.m. CET. If you missed last week's project on customer segmentation using K-means clustering, check it out in the description. But today, we're diving into something super exciting, sentiment analysis on movie reviews. So, what is sentiment analysis? In simple terms, it's the process of determining the emotion behind a piece of text, whether it's positive, negative, or neutral. Think about this: when you read a movie review that says, "This movie was absolutely amazing. The cinematography was breathtaking," you can tell it's a positive review, right? But how can a machine do this automatically? That's where natural language processing (NLP) comes in. We can train a machine learning model to recognize sentiment in text using a labeled dataset. Sentiment analysis is used everywhere. Here are some common applications. Product reviews, understanding customer feedback for e-commerce sites like Amazon and Walmart. Social media monitoring, tracking brand sentiment on Twitter, Facebook, and Reddit. Customer support automation, AI chatbots detecting user frustration in support tickets. Stock market predictions, analyzing public sentiment on stocks and cryptocurrencies. Let's explore how we can implement this using Python and machine learning. For this project, we'll use the IMDb Movie Reviews dataset, which contains 50,000 movie reviews labeled as positive or negative. As you can see, each row contains a movie review and a label, positive or negative. Before training our model, we need to clean the text data, remove special characters and punctuation, convert text to lowercase, remove stop words, common words like the, is, and, tokenization, breaking text into words, lemmatization, reducing words to their base form. Now, our dataset is clean and ready for the next step. Since machine learning models can't understand text directly, we need to convert our words into numbers. We'll use TF-IDF, term frequency inverse document frequency, to extract features. TF-IDF helps our model understand which words are most important in a text. Words that appear frequently but aren't common, like amazing and a positive review, get a higher weight. Now, our text is transformed into a numerical format that we can feed into a machine learning model. Next, we'll train a logistic regression model to classify movie reviews. As you can see, our model achieves an accuracy of around 85 to 90%, which is quite good. Let's test our model with some custom reviews. Try this with your own movie reviews and see how well the model performs. And that's it. We built a complete sentiment analysis model from scratch. For those of you who want to go deeper, try using naive Bayes, random forest, or even deep learning models like LSTMs to improve accuracy. Next week, we'll explore stock market analysis. We'll analyze historical stock trends and apply time series forecasting techniques. Like this video if you found it helpful. Subscribe for more weekly data science projects. Share your results on LinkedIn/Twitter with hashtag Let's Talk About Data. See you next Saturday at 7 p.m. CET. Until then, happy coding. Welcome back, Data Warriors. You're watching Let's Talk About Data. This is episode 3 of our weekly data science project series, dropping every Saturday at 7 p.m. CET. Today, we're diving into something that fascinates everyone, stock market analysis using Python. We'll uncover trends, identify patterns, and visualize stock performance using historical data. Whether you're a finance enthusiast or a curious analyst, this project has real-world applications and serious learning value. Here's what we'll cover in this project: loading historical stock data, data cleaning and time series formatting, moving averages and Bollinger Bands, correlation with other stocks, visualizations with Matplotlib and Plotly. For this project, you'll need Python, Jupyter Notebook or Google Colab, eFinance, Pandas, Matplotlib, Seaborn, Plotly. Internet connection to fetch live stock data using the Finance API. Don't worry, I'll walk you through every command. Let's begin by importing the required libraries and fetching stock data from Yahoo Finance. We'll use Yahoo Finance API to fetch historical data for Apple Incorporated AAPL. Boom! You've got all the data you need to begin analysis. We'll now clean the data and plot key trends. Plot closing price over time. Add a 50-day and 200-day moving average. Visualize Bollinger Bands. Let's see how Apple correlates with other tech stocks like Microsoft or Tesla. This gives you insights into portfolio diversification. You've just learned how to do real-world stock trend analysis using Python, from pulling the data to building insights. This kind of analysis is useful in finance, investment analytics, fintech startups, and data storytelling. So go ahead and try this project yourself. If you like this video, give it a thumbs up, share it with your fellow learners, and hit that subscribe button. Next week, we're going deeper with house price prediction using linear regression, a beginner-friendly but powerful project in real estate analytics. Also, if you built this project, share it online with the hashtag Let's Talk About Data, and tag me. I'd love to feature your work. See you next Saturday at 7 p.m. CET. Until then, stay curious and keep coding. Welcome back to Let's Talk About Data. Today, we're tackling a problem we all face: spam emails. We're going to build a robust spam classifier using natural language processing, NLP, and machine learning with Python. If you've ever wondered how these spam filters work, you're in the right place. In this tutorial, we'll go beyond the basics. We'll cover everything from understanding the dataset to deploying a practical prediction function. By the end, you'll have a solid foundation in NLP and machine learning for text classification. We'll dive into advanced text preprocessing, explore feature extraction with TF-IDF, and analyze the performance of our model in detail. This isn't just about coding, it's about understanding the concepts behind each step. Don't forget to hit that like button, subscribe, and ring the notification bell for more in-depth AI and data science tutorials. Let's start by understanding our dataset, the SMS Spam Collection dataset. It's a classic for text classification, containing thousands of labeled messages, spam or ham, non-spam. Dataset structure. We have two columns, label and message. Label indicates whether a message is spam or ham, and message contains the text itself. Let's look at a few examples. Example 1. Winner. As a valued network customer, you have been selected to receive a £900 prize reward. To claim, call 0906170141. Claim code KL341. Valid 12 hours 1 only. This is clearly spam, with urgent calls to action and promises of prizes. Example 2. Even my brother is not like to speak with me. They treat me like AIDS patent. This is a typical ham message, conversational and personal. Notice the differences. Spam often uses all caps, exclamation marks, and urgent language. Ham messages are usually more casual and informative. Understanding these patterns is crucial for building an effective classifier. Now, let's set up our Python environment. First, ensure you have the necessary libraries. Open your terminal or command prompt and type pip install pandas numpy scikit learn nltkit. These libraries are essential for data manipulation, machine learning, and NLP. Now, let's import them into our Python script. Import pandas as PD, import numpy as NP, import import nltk from sklern.model_selection, import train_pist_split from sklern.feature_extraction.text, import fit vectorizer from sklern.naive base, import multinomial nb from sklern.metrics, import accuracy_classification_report. Next, load the dataset. df equals pd.read_csv spam.csv encoding equals Latin 1. df equals df1 v2 def columns equals label message. Let's confirm it's loaded correctly. Print df.head. Text preprocessing cleans and prepares our text data. Raw text is noisy and unstructured, so this step is crucial. Let's break down each step. Removing special characters eliminates non-alphanumeric characters like punctuation and symbols, which don't contribute much to meaning. Converting to lowercase ensures consistency. Hello and hello are treated the same, reducing data dimensionality. Tokenization splits text into individual words or tokens, essential for further processing. Stop word removal removes common words like the, is, which don't carry significant meaning, reducing noise. Lemmatization reduces words to their base form. Running and runs become run, ensuring variations are treated the same. We convert to lowercase, remove non-letters, tokenize, lemmatize, and remove stop words. Let's test it. The output clearly shows the transformation from the raw, noisy text to a cleaner, more normalized version. The pre-processing steps, lowercasing and punctuation removal, are fundamental in many text processing tasks as they help to standardize the text and reduce the number of unique tokens, making it easier for algorithms to analyze. Now, we convert text to numerical features using TF-IDF. TF-IDF, term frequency, inverse document frequency, measures word importance in a document relative to the corpus. We initialized fit vectorizer with 5,000 features, fit and transform the cleaned messages, and convert labels to numerical values. We also split the data into training and testing sets. The feature names output shows that the vocabulary includes words like AA, ati, etc. Sample TF-IDF vector output shows that the word AA has a TF-IDF score of 0.0 in the first document. The word has a TF-IDF score of 0.0 in the first document. The other displayed words have TF-IDF scores of 0.0, meaning they either don't appear in the first document or are considered very common and therefore not very informative. We'll use multinomial naive Bayes, well suited for text classification. Accuracy shows overall correctness. Precision, recall, and F1 score provide deeper insights. Precision measures correctly predicted spam. Recall measures correctly identified actual spam. F1 score balances precision and recall. Let's analyze the classification report. A high precision for spam means fewer false positives. A high recall means fewer false negatives. Win a free iPhone now, click here. This message contains phrases commonly associated with spam. Free, win, click here. After preprocessing and vectorization, the TF-IDF vector will likely have high values for terms that the model has learned are indicative of spam. Therefore, the model.predict function should return 1, and the predict underscore function will return spam. Hey, let's meet for coffee tomorrow. This message is a typical non-spam message. It contains casual language and a normal request. After preprocessing and vectorization, the TF-IDF vector will likely have values that are not strongly associated with spam. Therefore, the model.predict function should return 0, and the predict underscore function will return not spam. We successfully built a spam classifier using NLP. Check out the GitHub link in the description for full code. Don't forget to like, share, and subscribe for more AI projects. Follow me on LinkedIn for more content. Let me know in the comments what NLP project you want next. Welcome back to Let's Talk About Data. In today's episode of our weekly Data Science Project series, we'll forecast future sales using time series analysis. Whether you're just starting or building your portfolio, this one's perfect for you. We're going to use historical sales data from 2022 to 2024 to predict future sales. You'll learn how to visualize trends and build forecasting models using ARIMA and Facebook Profit. Our dataset contains daily sales from January 2022 to December 2024. It has 2 columns, date and sales. Each row shows the total sales for that day. pd._m. Make sure our dates are in proper format. We set the date as the index to use time series functions. Resample ensures daily data, and filna fills missing days by carrying forward the last value. We're visualizing how sales fluctuate over time. This helps us spot trends, seasonality, or sudden changes before modeling. ARIMA stands for Auto-Regressive Integrated Moving Average. Order equals 5 and 1 kano means 5 lags for autoregression, 1 difference to make data stationary, and 0 for moving average. We forecast the next 30 days based on learned patterns. Profit requires column names DS, date, and Y, value. It models trend, seasonality, and holidays automatically. We create a future data frame and predict sales for 30 days ahead. Profit generates clean and interactive forecasts, including uncertainty intervals, very handy for business planning. Today, you learned how to prepare time series data, visualize sales trends, and forecast future performance using 2 powerful models. A must-have skill for any data analyst or data scientist. Challenge for you. Use this approach to forecast temperature, energy usage, or website traffic. Drop a comment or share your results tagging "Let's Talk About Data." Next Saturday, join us for Project 5, Fake News Detection. We'll use NLP and machine learning to identify misinformation in news articles. You don't want to miss this one. If you enjoyed this project, hit like, subscribe, and turn on notifications. We're dropping weekly data projects every Saturday at 7 p.m. set on Let's Talk About Data. See you next week. Welcome back to Let's Talk About Data. In this week's project, we're diving into the world of media and misinformation by building a fake news detection model using natural language processing and machine learning. How to clean and pre-process text data, vectorize text using TF, IDF, train and evaluate ML models for text classification, build a simple app to classify fake versus real news. We import all necessary libraries for data handling, visualization, text feature extraction, machine learning, and evaluation. We're loading the dataset and inspecting the first few rows to understand its structure. Cleaning the data by removing missing values and selecting only the columns we need, text and label. We convert the categorical labels into binary values so ML models can work with them. Splitting the dataset into training and testing sets, 80% training, 20% testing. We use TF-IDF to convert text into numerical features based on word frequency and importance. Training a logistic regression model on the TF-IDF vectors. We evaluate the model using accuracy, confusion matrix, and precision or recall or F1 score. You can enter a custom news article and see if the model classifies it as real or fake. Naive Bayes is often great for text classification. You can compare its performance with logistic regression. Summary: preprocessed real versus fake news text. Extracted features with TF-IDF. Trained ML model to classify articles. Tested accuracy and made predictions. This project is a great example of how data science and NLP can be used for social good. Try using other models like Naive Bayes or VM for comparison. Try using headlines only instead of full articles. Can your model still detect fake news accurately? Thanks for watching. Download the dataset and code from the link in the description. Don't forget to like, comment, and subscribe. Next Saturday, Resume Parser with NLP. We're making job search smart and automated. Welcome to Let's Talk About Data. In this project, we'll build a resume parser using Python and NLP techniques. You'll learn how to extract skills, experience, education, and contact info from unstructured resume files, just like the ones used by real companies. We'll use sample PDF resumes. You can download resume templates from Overleaf CV Templates, Canva. Your own for testing. Create a folder named Resume/ and place your test resumes in PDF format. Setting up the environment. Resume File Format Overview. We'll use PDF Miner to extract text content from resumes. Unlike Word documents, PDFs require low-level parsing. Extracting text from PDFs using PDF Miner. Cleaning and pre-processing text. Extracting name, email, phone. For name, we use Spacey. Custom skill matching from Resume. Extracting education and degrees. Extracting work experience snippets. Find output dictionary. Automating Resume folder parsing. Real-world use. Integrate with ATS, applicant tracking system. Use named entity recognition for company names and job titles. Add Word/docx support using docx to text. Enhance skills extraction using embeddings or SPACI patterns. That's complete Resume Parser project using Python and NLP. You now have a real-world tool that can be used in recruitment, HR analytics, or even freelance automation work. Next week, Project 7, Real-Time Weather Forecast App using API plus Python plus Dash. Like, share, and subscribe to Let's Talk About Data for more hands-on projects every week. Hey everyone, welcome back to Let's Talk About Data. In this project, we're building a real-time weather forecast app using Python, OpenWeatherMap API, and Dash by Plotly. This is Project 7 in our weekly data science project series. Whether you're a beginner or looking to add a real-world project to your portfolio, this one is both useful and impressive. Let's jump in. First, let's install the required libraries. We'll use request to call the weather API dash and dash components for UI Plotly for visualization. Run this in your terminal or Jupyter notebook. We'll use OpenWeatherMap for live weather data. Head to https://openweathermap.org/API. Sign up for a free account and get your API key. Let's write the function to fetch weather data. Here's what the response looks like when you search for London. We'll extract temperature, weather condition, humidity, and wind speed. Creating Dash app layout. We have an input box for city name, a button, and an area to display the result. Weather display logic. This code will automatically fetch and display weather details after clicking the button. Run the app. Now open your browser at http://127.0.01 to 8050 and try entering different city names like Tokyo, Berlin, or Warsaw. recap. Let's quickly recap what we learned today. We integrated Open Weather Map API, built a live dashboard with Dash, created a functional real-time app from scratch. In week 8 of our data science project series, we're diving into computer vision. We'll build a convolutional neural network, CNN, that can accurately recognize handwritten digits from the popular MNIST dataset. You'll learn how to pre-process image data, design your first CNN architecture, train and evaluate the model, and even visualize predictions in real time. Perfect for beginners stepping into deep learning in AI. Set a reminder for next Saturday at 7 p.m. CET. Don't miss it. Subscribe now and turn on the bell so you're notified as soon as it drops. If you found this project helpful, hit the like button, share with your friends, and don't forget to comment your thoughts and questions below. Get the code on GitHub and follow Let's Talk About Data for more projects like this every week. Hey everyone, welcome back to Let's Talk About Data, your home for practical hands-on data science projects every Saturday at 7 p.m. CET. This is week 8 of our weekly series, and we're about to jump into the world of computer vision. We'll be building a convolutional neural network that can recognize handwritten digits. Yes, we're talking about the iconic MNIST dataset. If you've ever wanted to understand how AI sees numbers, this project is for you. If you're excited to build real-world data science projects every week, don't forget to hit the like button and subscribe right now. It really helps the channel grow and reach more learners like you. What is the MNIST dataset? The MNIST dataset is a classic in the machine learning world. It has 70,000 grayscale images of handwritten digits from 0 to 9. Each image is 28 by 28 pixels, small enough to train fast but complex enough to challenge your model. If you want to follow along, open up your Jupyter notebook or your favorite Python IDE, and let's get started together. Setting up the environment. We're using TensorFlow to build our CNN and Matplotlib to visualize our data. If you're new to TensorFlow, don't worry, we'll explain every step. Let's import our libraries. If you're coding along, type these imports out and drop a comment saying, "I'm with you." load and visualize the data. Isn't that amazing? This is what the model will try to recognize: real handwritten digits. These are not just numbers, they are the foundation of AI vision. Data preprocessing. We're normalizing the pixel values and reshaping the images so that TensorFlow can process them properly. If this is your first time working with image data, hit that like button because you're leveling up today. Building the CNN. This CNN has 3 convolutional layers, 2 pooling layers, and 2 dense layers at the end. It's simple, clean, and highly effective. Compile and train the model. We're training for 5 epochs, and even that is enough to get great results. Watch those accuracy numbers go up. While the model trains, let me ask you, what other vision-based projects would you like to see on this channel? Comment your ideas below. evaluate, and predict. And boom! We've built a digit recognizer that works with over 98% accuracy on test data. Visualize the predictions. This visualization shows whether the prediction was correct. Blue means correct, red means wrong. It's super helpful in debugging model errors. So what did we do today? We explored the MNIST dataset, built a CNN from scratch, trained it on 60,000 handwritten digits, and visualized our predictions. Give yourself a round of applause, and if you're still watching, leave a comment. Week 8 complete. You're amazing. Next week, we'll dive into Project 9, Credit Card Fraud Detection. We'll use a real-world anonymized dataset and apply machine learning to detect fraudulent transactions, something that's used in banks and fintech every day. Subscribe and hit the bell so you don't miss it. Hey everyone, welcome back to Let's Talk About Data. This is week 9 of our Data Science Project series, and today we're diving into a real-world problem, one that banks, fintechs, and governments care about: credit card fraud detection. We're going end-to-end with real data, powerful models, and loads of insights along the way. If you're new here, don't forget to like, subscribe, and hit that bell icon so you don't miss week 10, where we build an autonomous web scraper with AI. More on that at the end of this video. Let's get started. Let's begin by importing our essential Python libraries. Now we load our dataset. You can grab it from Kaggle, link in the description. If you're coding along, pause the video and load up your notebook. I'll wait. Let's take a peek at the data. First, let's check for nose, shape, and class balance. only 0.17% of our data is fraud. This is very imbalanced, and that's a challenge we'll tackle shortly. Let's plot the amount distribution and correlation heat map. Comment below if you've worked with imbalanced data before and what techniques you used. Let's normalize the amount column and drop the time column. Separate features and labels. Now, let's split the dataset using stratified sampling so our test set represents both classes. We'll keep it simple with a random forest classifier for now. Let me know in the comments if you want us to explore XGBoost or deep learning in future projects. Let's make predictions and evaluate the model's performance. Here, we care a lot about recall. We'd rather catch false alarms than miss actual fraud. Let's visualize the confusion matrix and ROC curve. You can save the trained model for future use with JobLib. Think about deploying this model in a Streamlit dashboard for your portfolio or in a real-time scoring API with Flask. Let me know if you want a deployment tutorial. Hit that like button if you learned something today, and drop a credit card emoji in the comments to let me know you're watching till the end. That's it for Week 9, a complete end-to-end credit card fraud detection project, all yours to explore and expand. Next week on Let's Talk About Data, we're building something really cool, an autonomous web scraper that not only scrapes data, it knows what to look for and when to scrape. Mind blown. So hit that subscribe button, turn on notifications, and I'll see you next week for some AI-powered automation.